right, welcome to Raising Funds for World Domination, day number 204. So today, I didn't really have a lot of time to think about or plan or prepare for what I would do for tonight's stream. So as the time approached, I kind of just thought, I'll just do whatever's the simplest thing with whatever's set up and prepared. So just set up the camera and the tripod, and I guess we'll take a look at some semiconductors. So that's some easy content that I haven't really ever done before. Just grab some random silicon wafers that I have and look at them under. This is not actually a microscope; it's just my DSLR camera. Let me change the exposure there. That's maybe good there. Yeah, so that there's the top part of the camera, and I just have the camera with a macro lens pointed down at the silicon wafer. And so for reference, oops, that's not good. I think I knocked out, or did I? Okay, never mind. I thought I knocked out the cable. So this here is that wafer. That's what we're looking at. Whoops. There's too much junk in front of me here. Yeah, so I don't really have any particular point, but we'll just chill and look at some semiconductors. Oh, that's hard in the mind. My camera is pointing this way, but figuring out which way to push it is going to be hard in the head. Yeah, so that thing, I guess I think that's used for like calibrating. So that's, let's see, I may change the lens throughout this stream so we can get a closer view. So that's one of the wafers up close. Basically just a repeating pattern of that same chip before it gets cut. And then of course around the edge of the chip, it's just they don't really try too hard. So it just cuts off chips right at the edge. Rick Brown, James says, pretty cool, Robert. Yep, I think so. So that's a look at one of the chips, or one of the wafers. I have a bunch of them. I probably won't go through all of them. Let's see. So that one is silicon. Pretty sure. How does your product of adding ore work? For example, add graphite ore to bulk mining simulation game. So for that, I will. So there's some config files where I just officially add it into the game. So there's in the help menu of the game, it'll appear in the help menu, and in the future, any future mechanism that I add, like the actual the process of refining ore, that's one of the next things I'll probably add is some more. Now that I can add crafting recipes, I'll probably add some crafting recipes to do more intermediate steps for the ore refining. But the delivery of that will basically be like a commit push. So I'll push to GitHub. And so I could point to a given commit hash where you could download the game, you could download the source code for the game, and that will be added to the game. I could probably explain that a bit better in the description. I lied, I don't have Netflix. We're going to look at ICs under a microscope. Yep. Let's take these off. Keep hitting stuff. I know the audio works. Okay, this is a more fancy wafer. I paid quite a bit more for this one. Actually, I don't even know if I've looked at this one under the microscope before. This might be new for me. So I'm just adjusting my tripod here to get this in focus. Kind of hard to see the monitor. I have a light here, and it's glaring on my monitor. Makes it hard to read chat too. Don't have a computer. I'm basically the underdog. In a way, I love being the underdog story of my life. You don't have a computer? How do you watch this video? Yeah, so I don't think I've actually looked at this one before. That one looks like it has a lot of pads on it. This must be must have a lot of, this must be like a fully fledged microprocessor or something. Let's see what's on my label here. This is a Dallas Semiconductor, 8051 compatible. I don't know my chips very well, but I connect the PS2 for visuals with the works of the Dreamcast connection. I'm just playing. Interesting. Let's see. So maybe I guess I'll swap out. Maybe first we'll try out the 4x objective. So this is, right now you're looking at this with a regular camera lens. So I guess I put my finger in the, let me go the other way. So there's what my finger looks like on this scale. And next we'll go with a 4x microscope objective attached directly to the camera. Let's put this to the side so I don't hit it. All right, let's change the lens. All right, lens has been changed. Okay, so I gotta go way further down. This is the issue with having you can get by without a microscope, but then you have to do way more work to get stuff actually in focus. I might need something to put this up on. What kind of lens is that? So the lens that's on right now, so this here is a 20 times microscope objective. The 4 times objective, which I have physically attached to the camera right now, is it looks the same, but it's just got like a red ink on it. Let me think. All right, just trying to figure out where the focal plane is. I guess I'm gonna need like a book or something. I'm just gonna grab a book. SDEESE says hello. How's it going? Wait, there's a book. So now let's put our wafer back on there. Oh, I can't see my monitor. Oh, that's out of focus. Okay, I think that's around maximum focus. So this is a closer look. This is with a 4 times objective. Book necessary for leverage, depending on how many chapters in the book. I just need something to prop it up. Prop up the wafer so it's in the right, so it's close enough. So yeah, that's a better view compared to what we just saw. There's the edge of the wafer. There's stuff written around the edge, but you can't read it. Pretty cool. They got 1080 display. Do you mean the camera or? All right, there's where most of the logic happens. I haven't actually looked at this thing up close before. I can't say much about it. I have to research it, but it looks like it's got a this must be like a pretty fully fledged like microprocessor. Given all the, I think all of those like little points, those like little silver beads, or like silver things there are pads to connect to. Or possibly maybe they're even for testing, I don't even know. You're joking? 1080? Yeah, I don't know what you're talking about. Orthoplex 64, how's it going? So that's that chip. And then maybe I'll just go back to compare the other one for scale, and then I'll change the objective again. Yeah, I guess that's pretty much the same scale as the last time. Now let's go with the 20 times objective. That's where it looks a lot more interesting. And I'll probably have to prop this up again. Actually, let me get my rotation stage. Two days ago, the ice tray of semiconductor chips display was pretty cool, but still got to be a better way to put them in baggies. I guess if you were doing a lot of them, there's probably a better way to automate it, but I don't have need more sales volume to support that. Okay, this will be the 20 times objective. And I'm gonna have to make that have to flatten that out. Right, now I gotta go with a much longer exposure time on the camera because it's so much darker. All right, there we go. Now the challenge is to get it in focus. All right, there we go. Oh, you can see something written there. I've never done a close-up of this before. Rockwell International Corp. Made in USA. A lot of cameras on phones have focus problem. That's true. They do. Quality goes down with every phone being sold. I find that the quality of the hardware gets like incredibly amazing, but the quality of the software is where it seems to really be lacking. Well, that's the edge. See, this is where it helps to actually have a real metallurgical microscope. So you're not just like touching it, trying to move it in the right direction. My XY automation stage would have been pretty good if I had have been able to get that automated. See, I'm trying to get a look at that thing in the center. There we go. Yeah, so I think that's a close-up of that test pattern. It's in the center of the chip, or there was in or the center. There's a few of those on one of the wafers, and I think those pads there are where probably some like testing process will connect to it, and then from that you just like you probe onto those points, and you can test all the chips in the wafer before you even cut it. There's a $3,000 camera right there. You can get real focus on the moon. But get damage to the lights, like a street light hits the lens. There was one camera that they were caught faking that, where they were just like using AI to upscale it. Oh, looks like those are numbered too. Not sure what that is. You'd have to ask a semiconductor engineer. I have seen some patterns on some of these that almost look like they're meant to like test the processes and stuff. So if there's a certain like process node that gets missed, there's like an easy way to look at it and say like, oh, the metallization layer is bad, or the epitaxy failed. Can't tell. Does that say something? It's hard to get to go beyond 20 times magnification. It's hard because you have to get so close to the chip that you can't actually. You can't, like right now I'm just using like a regular lamp to illuminate this thing, but when you go higher magnification, you have to get closer. You have to get the objective closer to the surface, and it gets like so bad you can't even really shine a flashlight on the edge of it. You can, but it doesn't give you the greatest consistency. All right, let's look at the other wafer. It's almost in focus. Not quite. I need like another 2 millimeters of height. There we go. All right, this is that other chip. So that one looks like it has I don't know if there's some writing on those pads. Oh, that's neat. I never seen one of those before. I wish I had my higher magnification. That'd be interesting to take a look at. It looks like a barcode, but it must be for some kind of calibration or something. Or testing. Almost may go to numbers on there. So a lot of what we're seeing is the metal layers on top, and the stuff underneath is not there. But if you put some like weak acid on this, and then you etched off the metal, you can see what's underneath, get a little bit more detail. That looks like a model number. You can Google that and then learn more about this. Used to have a telescope, but I gave it to my younger cousins. Wish they took care of it. That's too bad, I guess. If you loan something out, you can't. You have to mentally come to terms with the fact that you might not get it back. Let's see, I gotta get my mind twisted around. There we go. Looks like there's a bunch of dirt and there's a red fiber there on top of the chip. I think that's just debris on top of it. It looks like this chip actually uses gold for the metal layer. I think some chips use aluminum. There's some more interesting details. So, from looking at these for a while, like toward the bottom of the screen, you can see this is the golden colored area, and there's a couple square things. I think that's the edge of the chip, the bond points on the edge of the chip itself, and then that outer area. I'm not sure what that maps to. That might just be like a testing substrate on the wafer. It was a gift. Just wish they appreciated it. Yeah, I guess sometimes you get people a gift and they really don't appreciate it, and it's a gamble. Sometimes you get people something and they really like it and they use it for years and appreciate it, but it's always a gamble. There's an interesting multicolored area there. I wonder if that's just like corrosion, or if there's some significance to that. This is only 20 times magnification, so I think those square pieces, I think usually those bond points, like the square features around the top and the bottom, those are around I think like 100 microns, so around like a tenth of a millimeter square. So that's still that's something you can see with your eye. So we're still pretty much like macroscopic scale. Need better equipment to see even more detail. The chip, I think it said it was from 1997. Was the chip exposed or damaged? It might have been. It looks in pretty decent condition. So those individual lines, those would be traces in the chip. And then over on the left-hand side, that square thing, that would be a bond point something, probably. So that's probably 100 by 100 microns. And so the traces are probably like 1 or 2 microns wide. It doesn't take much to carry an electrical signal. Remember the how to make a CPU video? Yep, it's my most popular video. Oh, there's a copyright thing on the side. 1997. Let's try to move that more into the frame. Let's see, that would be like this. There we go. So it's hard to get both those in focus perfectly at once, because I think the DS8F520 is like raised up. It's probably like a few microns higher than the 1997. How much money you make from that? It works out to about $1,000 per million views. But the issue is that video, that's my most successful video on the channel. And I have other videos that I've put just as much work into, and the other videos get like $10 in revenue and like 2,000 views, but that one got 17 million. So if they all got 17 million, I'd be doing pretty well. Oh, thank you very much to Devin for $2 for the New World Order. Thank you very much. Might have to get a laser pointer for that camera to get more focus. Besides, cat red lights. Red lights apparently approves eye production, if not mistaken. Eye production. I mean, red laser pointer for pointing stuff on this. This is under a microscope, so it'd be hard to use the laser pointer on it. All right, that's good for that chip. And let's put a couple more. Actually, all right, here's the next chip. Or the next wafer. Casola's land says T. Yes. Oh, is that some text? I think it is. One 10462. $120 PF test C. If I'm gonna guess, I'm gonna guess maybe PF means picofarad. Maybe they're testing the capacitance of something. Rockwell International. I'm watching what the purple thing does in the live chat. Oh, do you mean that number 1 crown that goes beside people's name? It has something to do with, like, they're trying to gamify, like, who's the highest ranked person in chat to get people to chat more or super chat more. So far, what I think it's built on, facts that the AI wants to consider facts for AGI besides how much you input. I don't know. Same text again. Can't tell what that says. A built-in software integer for dominated control would consider what it would want to be considered facts for collect data. I have trouble making sense of that. What are you doing? I'm currently looking at silicon wafers under a 20 times microscope objective. So what I'm currently looking at is one of these. And it's got a bunch of little squares on it. And so each of these little square areas, are they CPUs? Basically, technically these ones These ones here, I think, much simpler chips. But these would be, these might be like small memory chips or something, but CPUs would be basically made the same way. I think if you go back a little bit earlier in the stream, I think one of the ones I was looking at before, like near the start of the stream, I was looking at one that had way more pads, and I think that one was actually a CPU. But for the uninitiated, it's all basically the same thing. So these ones here, I don't know what these do, but like those kind of repeating. These must be actually pretty old chips. Are you looking here to learn? Or just trying to gain something from doing this? I've been doing this this series, raising funds for World Domination series. For this is day 204. So I figure I'm obligated to keep up my pattern. Tonight I didn't really have a lot prepared. I have been doing work on my terminal-based video game, but I said that by day 200 I would try to finish it, publish it, and then take a break and just experiment with, do some streams of other random stuff. So tonight we're just trying out this. So again, it's all just part of an interesting experiment to see what kind of content do people like more. Do people like looking at random microchips under a microscope on a live stream? It is kind of like I do have a bunch of these chips. It's been on my to-do list to like just look at them for fun, see what's on them. Sometimes you see, every time I look at them, I learn a little bit more about how to actually manufacture these things and what they're probably doing. Like those things there with, I guess I can't really point to it, but you can kind of see those 1, 2, 3, those 5 square points there. There's like I think it's got F1, F2, F3, F4, F5. Those might be for testing. Like after they finish making the chip, they might probe onto those. Actually, it even looks like there's in the center, on the edge of it, you can kind of see an area where it's smeared. It looks like it's been almost, it's like a smudge on it. My guess is that's probably where, during the manufacturing of this, they probably probed onto it, and that distorted the color a bit. And that was how they concluded this was going to be a reject wafer, because they tested it. So it failed one of the tests. Some of these I've looked at before, but it's never been high priority enough to take a look at. So I figured I don't have any content prepared for tonight. I'll just take a look at some random chips I have. Okay, I think that's enough for this one. Does this genuinely interest you, or you're just doing this because you're run out of ideas? I'm not out of ideas. There's lots of things I could do, but there's only to prepare more interesting stuff. It just takes time, which I don't have when you're doing one live stream of something every single day. Semiconductor manufacturing does, in fact, interest me. Somebody has to figure out how to make CPUs. Otherwise, who's going to make those 17 million view videos about how to manufacture CPUs? Lovely to see how my purple thing went from number 1 to number 3. Because when I mentioned what I said earlier. Yeah, I don't know. Maybe the AI agrees with you. I think it might actually be related to how many times you chat something. Robert is legit. That's true. Why do you think there is a psychological distinction between people who choose to go by Robert, Rob, or Bob? Do you think there is a psychological difference? I've never thought about that. It probably just depends on what era you grow up in and what. I don't know. I think Rob is probably. Robert was a more popular name in the past. I think Bob is. I don't really like how there's a standard of like names. They could be totally different. Like it's not even a subset of the real name, but people still use it interchangeably. Like Bill and William. I was quite old before I knew that Bill and William are the same name. And there's another one. Jim and James are like apparently the same name. I think I was 20 something, in my late 20s by the time I realized that. So I think that one's also Rockwell. You see a copyright up there. I just learned about Jim and James in my late 20s. So thanks. Yeah, to me that should be illegal to consider them the same, because they're not. Rockwell International Corp. So this one, based on the color, I'm going to guess that it uses aluminum for the interconnects as opposed to gold. Legendary Chicken says, hello, Robert. How's it going? This chip's not quite as interesting. Once again, on those square points, on those square things, you can see like a discoloration or a bump or something, or maybe even a dent near the center of them, and I think that's where they've been probed onto, where during the manufacturing they like put a probe onto it to test it. And this area is this repeating pattern. It's almost certainly some kind of data storage. Let's look at that pattern in the center. It's not much interesting on that one. Well, I think that's about it for this chip. What do you guys think? Do you want to see more? Is everyone excited? I can go get some more chips, and if you want, look at those. Or we can call it a night. I'm fine either way. Well, I need some conviction. How about this? Type a 1 in the chat, and I will go dig out another chip, and we can look at that. Just yes, that's not a 1. Yeah, I demand that someone put a 1 in the chat, and then I will go dig out another chip. All right. All right, I got a couple more here. Let me just put these away so I don't lose them. Okay, that's an interesting looking one. I don't think I've looked at that one yet. What is it with that one? Okay, we looked at that one and this one. Black room processor chip? I don't know. Well, there's some text. OX4. I'm not sure what these chips are. They might be some kind of memory chips. It's not like regular. There's like, you can see there's an alternating pattern in there. I don't have high enough magnification to see what it is, but anytime you see like something repeated over and over again, it's probably memory. And then this over here, this makes me think it's actually if I change, no, I wonder if this isn't a chip that was abandoned halfway through. Memory that feels like a book being flipped, I guess. This makes me think it's this chip, the reason I have any of these wafers is because they're defects. So this may have been one that was not finished, and they were in the middle, like, because during some stages of the process, they'll put down a layer of metal, and then they'll do another like etching process and stuff. But during some stages, there may just be like a flat piece of metal on the top, because that was just happened to be what they were working on, and then they realized that they did it wrong. They put like the metal is too thick or too thin or something. So there's really not a lot of interesting detail on it. My bad memory that folds like a book being flipped. That sounds pretty rough. Lots of dirt on this one. I think from some of these are just like cheap defect wafers. So I think a lot of them have, like, they're not really cared for. Wherever they come from, that person just like, they throw them in a pile, so they get all scratched and destroyed. That's interesting. There's, I wonder if that's like, I wonder if that's where they tried to like fix something or probe something. Does that look like that line that's etched into it? Looks like it was made with like a lot of precision. I wonder if it's like an ion beam thing or something. Like they were testing something. Is that dust, or is that a... I don't think that's a connecting line. Yeah, I wonder. That almost looks like this almost looks like they were like trying to fix something. Or is it just like gunk that's managed to get into these crevasses? Here's a blue area. Neat. How old is that chip? I'm not sure. It's probably at least like the early 2000s. Is that a microchip? Yes. Yes, this is part of a wafer. It's a reject wafer that's in my possession. So there's a bunch of chips on it. I'm not sure what these chips do. I think it was like rejected in the middle of being fabbed. So I think probably they were like halfway through the process and realized that it wasn't good or something. Or they might just be like memory chips. All right, that's enough on that one. Is this valuable? I would say no. You can buy, there's tons of like wafer, reject wafers you can buy. There are some wafers like in terms of actual percentage, most of the wafers that are made, like when you think about like microchips and stuff, people think about processors because that's what you buy and that's what's the most useful and valuable. But like by sheer number, the most of the volume of microchips is like really simple stuff, like memory chips or chips that go in like small embedded devices and stuff. So that's what if you buy like scrap wafers, that's what a lot of it will be. Okay, that's totally upside down then. Here we go. What does that say? 1986, Rockwell International Corp. What are we doing today? We are looking at some microchips. I didn't really have time to prepare anything today, so I figure I'll just do the easiest stream that I can. Take a look at some chips. Experiment with new content. My how to make CPU video is trending, so it's relevant. It's relevant to where most of the new viewers are coming from. So yeah, this was it 1986, and it's already this small. So today it's even smaller. Can I modify the chip by hand? Like a chip like this? It depends what you mean by hand. I think in like experimental research labs, they have like an ion beam, so you can, like if you have industrial school tools and stuff, you can like, to some degree make modifications to the chip afterward. Like for example, those square features down near the bottom of the screen. Those are the pads that would connect it to the outside world. Those are, I think, let's see, I guess, yeah, you won't really be able to see my finger, but those squares are about 100 by 100 microns. So what would it be? 1, 2, 3, 4. Yeah, so each of those pads is about 1/10 of the thickness of a dime. So they're quite small, but you can see them with your naked eye. And like theoretically, with a magnifying glass or something, you could do some basic changes. Like if you wanted to short something to ground, or maybe connect two of those pins together, you could probably even do that with just a magnifying glass. It'd be really hard. You might damage the chip. But if you want to do more than that, there's probably some. If you know like everything about the chip and how many layers it has and stuff, you might be able to make certain kinds of modifications. But you'll be limited to just like really simple stuff. Like there might be, I'm sure there's certain chips where if you short one of the pins to ground, or if you connect it to VCC or whatever, then you can change how the chip behaves, and things like that you could do without sophisticated tools. It'd be like really hard, but like you'd be trying to poke something that's less than the thickness of a dime by hand, but so it's not impossible. What do people do when they add chips to consoles? What do you mean by that? Add chips to consoles? Do you mean like aftermarket modifications to consoles? If I get the same lenses from the eye doctor that corrects as a tool, what that possibility, would it still be able to keep my eyesight besides using that tool? If I get the same lenses from the eye doctor that connects as a tool, that question makes my brain hurt. I don't know. You'll have to ask the eye doctor. There's another piece of text, but I can't read it. ZFX. All right, there's one of the calibration patterns that's in the center of the wafer. Rockwell and Moss. Aftermarket modification, most likely if you, like when they add a chip, what they would do is they would have some chip, and the chip would be packaged. So this is an entire wafer. In the manufacturing process, after you have a wafer that's finished, you would dice the wafers. You would dice the wafer into individual chips of the actual silicon. This has not been diced; it's still in a wafer. Then you package those in some way, and often there's like an epoxy package, so it's a piece of plastic. And in addition to that, like those silvery square things, those would be some of the bond points on the chip. And so you would like extrude a piece of metal and connect those to like the physical legs. If you've ever looked at like if you opened up electronics and you see microchips and there's like pins sticking out of these black chips, those pins would get connected internally to those silver squares, and that's how the actual silicon chip gets connected to the outside world. And for like aftermarket modification, you would get one of those pre-packaged chips that does something specific, and most likely the chip is designed with knowledge of like how all the other chips work. So most likely they're not actually modifying other chips on the board. What they'll do is they'll just like they'll maybe like sniff some of the information, or they'll connect to some data lines of another chip. So they'll change data as it's being moved back and forth, or they'll maybe connect something to ground or connect it to VCC. Exactly what they do depends. Like an eye doctor, chronic division could be used as a tool for microchips. Probably not. Hey, Robert, what are you doing right now? Just joined stream. Robert, question mark. What about Arduino, Robert? What about an Arduino? Right now we are looking at some microchips with under a microscope objective. Without the side effects, because that would be considered like wearing glasses, because your eyes adjust to the different lenses. Yeah, maybe you're talking about like if you got like microchips, or if you got like microscope objectives as your glasses lenses. But if you did that, you would only be able to see, like you can only the objective lens, this lens only works when it's like 3 millimeters away from whatever you're looking at. So if you got glasses that were microscope objective lenses, you wouldn't be able to see from far away. You'd have to like go right up to a wall, and you'd only see like a tiny fraction of it. Raspberry Pi, Arduino are pretty good to interface with stuff. Yeah, I think actually some of the prototyping for when people want to like modify game consoles and stuff, or like drive other devices, if you want to like prototype those things, you could prototype chip modifications using an Arduino to externally drive stuff, because then you can just reprogram the Arduino in software. But then to miniaturize that solution like if you want to have a sellable solution to do a mod, because the Arduino is physically large, you don't want to have to put an Arduino in your game console. But once you know exactly what the modification is, you can miniaturize that in a chip. Thought it was a good question, because we're already having problems with cameras trying to focus on microchips. Actually, the focus, I'm doing the focus manually, so like that focus is from me. Like I'm physically, there's a little like screw here, and I'm turning the screw, which moves it up and down just a little bit to get it in focus. Have you heard of removing all ads on your network using Raspberry Pi? I have heard of that. I haven't really cared much enough to do it though. Why is the stream not loading? The stream? I don't know. What chip are you looking at? I guess this is a Rockwell NMOS chip from, I think it was 1980 something. What's the chip? It's a Rockwell NMOS chip. I don't know the actual like part number of it. (1986) Rockwell International Corp. My guess is it's probably a memory chip. Can I interface with a relay with 5 volts? I don't know. There's a whole bunch of pins on it you'd have to interface with. It's just it's like a bare wafer, so. And also I think this chip is in my possession probably because it's a reject chip, so most likely it's a problem with the actual dies. Can I program it to replay things that I put in? Maybe. I still don't know the exact function of it. If it's a memory chip, then I guess maybe you could store some data in it and then read it back out, but I'm not sure if there's any like control logic or anything in it. Some people throw away microwaves because they are too slow to warm up things. But there's perfectly good components and transformers in there. That's true. There's also perfectly dangerous components in there. Safety second. Not with microwaves though. I actually got I even got an advertisement from the government that was warning people about playing with microwaves, because apparently there's been like a lot of people have actually died. And one of the there's like this popular technique of using microwave transformers to get high voltage and to make these like artistic patterns. Work with 20 kV, not that dangerous. It depends how much current it can sustain, and there's a lot more factors that are important than that too. And I guess because they're because it'll be like galvanically isolated. It may, if you electrocute yourself on it and short circuit it, then it may not necessarily trip a breaker. So that'll mean like if you get shocked, you'll like continuously dump energy into you. Whereas if you just like if you go in your house and take like a bare, like if you shove a fork into the electrical socket, you'll get a shock, but after probably a second or something, it should trip the breaker. But with microwaves, that's not necessarily true because of the transformer. Play appliances with outdated motors. Plenty of appliances with outdated motors. I'm sure that's true. Safety third. Made a 4 kV transformer. Have you seen what's this Photon Inductions channel? He had some very interesting, dangerous videos. Actually, I should check out his channel. I haven't watched any videos by him in a while. Rockwell International Corp. Well, I think I've explored this topic thoroughly tonight. I could go through some more chips, but I'll probably leave it there for tonight. Maybe go to bed a bit earlier tonight. Yeah, I don't know. Maybe, I guess I'll be consistent with my recent pattern. Got into Wikipedia rabbit hole. Rockwell Corp made drills calculators, in the space shuttle Endeavour. Yeah, they did a bunch of like military contracting stuff. I think Rockwell got acquired by some other company. I forget what, but I think they're like a part of the fragments of them got acquired into the military industrial complex. But I'll probably leave it there for tonight. And we'll be back tomorrow night. I guess maybe I'll have to do a walking stream. I'm doing a walking stream every other day. I think I fixed the monetization issue. I found a setting to like... I had to go into the live dashboard and then click a setting that says like apply this monetization setting to third-party platforms. I think that'll make it work, but we'll find out tomorrow night, and I test it again. All right, have a good night, everyone.